Please, Josephine Danso.
And I'm Zara Malaika Nyami, and we are second year petrochemical students. The name of our app is Thermodrive, and I'm here to explain the lines of code. In this section, as you can see, we are importing the needed libraries. So we import Streamlets because it helps to transfer or transform the Python codes into interactive web pages. NumPy is for the mathematical and arithmetic aspect of the code, and Matplotlib is for the graphical aspect. So to begin, the Brayton cycle plot. This line, the def plot Brayton, is basically defining the function to plot for the cycle Brayton. The fixed axis here is basically creating the figure and axis that we need to draw the graph. This are thermodynamic constants, and these are other variables necessary like the entropy values, the pressure values, the temperature values that will all be plotted on the graph. And this is to label the graph. So this labels every line that will be shown on the graph, the compressor in, out, turbine in and out. Then we start with the plotting, the labeling of the plot. X labels that the axis, and the Y label also labels that axis. This is the title of the whole graph. And we added this code, the AX grade true, because it makes the graph easier to understand. And also we had to call the library in the code so that the lines of code you've typed will transform into a interactive web page. So the same goes for all the other cycles. The auto cycle, same format. This defines the code. You take the needed variables, you name the axis, you call the library. Same for Rankine and same for Diesel. Then the second second section of the code. This is the title you see when the web page is opened. You see thermodynamic cycle calculator. This line also gives you the options. So there are four cycles integrated inside our code: Brayton, auto, Rankine, and Diesel. The if section gives you the option. So if you choose Brayton, this is the header that will come. These are the values you'd have to input. This is what it will calculate. This is the comments that will be written when the calculation is complete or when it's successful, meaning all the variables you inputted are correct and reasonable. Then of course we integrate the plot code underneath. So that's the same for auto cycle, Rankine cycle, and the Diesel cycle.
Okay, so we use Virtual Studio Code to run our Python codes. Yeah, so to run the app, you come to the three dots here, terminal, go to new terminal. Yeah, so the PS you see here means you are using a PowerShell or a command line tool in Windows, whilst the C uses del means a current folder or a location on your computer. This basically means that it is waiting for you, the user, to type. Okay, so you type cd desktop, enter. Next you type your code, py space -m space streamlet space run, then and the name of your app, Thermodrive. Underscore app.py. Okay, so here the py means Python, the -m means run a model, the streamlight means a Python It's basically a Python library used to create web apps like dashboards, apps for data, and many more. Whilst the run means run a model, and the Thermodrive is the name of your app. Yeah, so this code actually means open a web page in your browser. Like this code opens a web page in your browser showing your app. Okay, so this is the app. This is the thermodynamic cycle calculator. Here you choose a cycle. For our project we use four types of cycle cycles, which is Brayton cycles, Otto cycle, Rankine cycle, and diesel cycle. So when you are done, you input values here. Yeah, if you want to calculate the specific heat ratio, you input your value here. If you want to calculate pressure ratio, you input your value here also. If you want to calculate your inlet temperature, you input your value here. Okay, so after inputting your value, it will calculate your your efficiency for you, and it will as well as show you the chart you want. This repeats for the other cycles. Thank you.